Good morning, ladies and gentlemen. This is Mr. Chen, filming another MCR3U grade 11 functions university level class on sinusoidal functions. We're looking at lesson 3 and activity 5, just very briefly. Hopefully you can see on the screen. I actually want to take a couple of these questions to help you guys out. Some of you might have some problems. So I'll create a new window. So we'll do actually maybe one of each question, and I'll read the problem to you, and hopefully it'll go okay. Again, as always, feel free to pause the video if I'm going too fast or if you need to hear it again. As always, you have resources from your package, the CEMC, and of course your textbook. So here we are. Activity 5 from lesson 3, sinusoidal functions, found on page 7. For each sine function, question 1, for each sine function described, write the equation and sketch the curve from negative 360 degrees to positive 360 degrees. And so for the first question, it says amplitude of 2 and period of 360 degrees. So for question 1, it said amplitude of 2, period 360. And I'm not copying this down properly. I even said 2, period of 360 degrees. So I would actually do a sketch. The equation of the axis or the midline is 0, and there seems to be no phase shift. So as a recap really quickly, the sine graph looks something like this. We have 5 critical points. And that's what you should get used to seeing. Like so. And so what I would do is redraw the graph. And that's 2, and that's negative 2. Instead it said, since it said go back to negative 360 to positive 360, so all we want to see is something like that. So what are our labels? That should be negative 360 degrees. That should be 0. That's positive 360 degrees. What about the other 2 zeros? This 0 over here would be 180 degrees. And this would be negative 180 degrees. How about the maximums? That's at 90. And that's at negative 270. How about the minimums? That's at 270. And that's at negative 90. So there you have it, ladies and gentlemen. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 critical points for this domain. Let's try a bit more challenging question. Let's try question 2. And let's try question 2. Let's try question 2D. And again, there's answers. 2D says amplitude of 2, period 2 pi over 3, phase shift pi over 3. So let's open up a new window. I already forgot what I said. Amplitude of 2. Period is what? 2 pi over 3. Equation of the axis is 0, because I didn't say anything. Phase shift is pi over 3. And I think that was positive. And we're dealing for cosine. So what do we want to do? Well, cosine graph, really quickly as a sketch. Looks something like that. Starts at a maximum, goes down to the x-intercept, goes to minimum, goes back up to x-intercept, and both goes back to the maximum. Again, I would do a sketch for this one. And that means plus pi over 3. So in English, this means left at pi over 3. So one more time, we're actually looking at this function. The way that we taught you. So we need to find how to draw this. So I would draw a sketch first of all, and then maybe I'll go to a grid so you guys can see it. So that's the grid, nothing with no numbers or anything like that. And don't get me wrong, you can definitely do it by transformations if you want. But I start off first of all with the equation of the axis. And so that's 0. How about where we're going to start? Where we're going to start is left at negative pi over 3. So that's where this point or this axis, the y-axis, is going to start. I know you're used to seeing at 0. Let's go back to this sketch here. You're used to seeing this at 0, and this is 0, right? But with a sketch, you're helping them plan out where those critical points are going to be. And so since the equation of the axis is gone, the phase shift tells us where we're going to start. But where are we going to end? It has to be 2 pi over 3. So if this is negative pi over 3, then this has to be positive pi over 3. And the reason why is because this should be then, if you really would need to see the x-intercept, or sorry, the y-axis, that's going to be here at 0. And this distance is 1/3 plus 1/3 is total of 2 pi over 3. So that's what we're going to have. Finally, we have to deal with this amplitude. Amplitude is 2. So since the equation of the axis is 0, that means this value is going to be 2. And that bottom is negative 2. The other two zeros are going to be at 0 and 0. So what's half of a third? Well, half of a third is a 6. So that's how we have it. We have our 5 critical points. And if you wanted to sketch this on a grid paper, so it's a little easier, and I'm going to have to transpose back and forth between them. That's okay. Let's do some lines. So a lot of you are more used to seeing. All right, that's good. So some of you find it easier. I have to delete that. Let's try that again. It's pretty good. And now we need some labels. Now I'm only going to do, if that's okay, I'm not going to do the total period. I just want to get this one cycle. And a lot of you understand where you can get that. So that's negative pi over 3. That's negative pi over 6. That's pi over 3. Or pi over 6. And that's pi over 3. So that could be 1. That could be 2. That could be negative 1. That could be negative 2. So going back to our sketch, our first point is at 2 at negative pi over 3. So 2 and negative pi over 3. Our next one is negative pi over 6 and 0. Negative pi over 6 over 0. And our third point is 0 and negative 2. And then our, whoops, went too far. And then pi over 6 and 0. and then back up to here. Right? So if you wanted to see a comparison to the actual graph, and I'll use purple here, for y equals cosine of x, and this is what the whole point is. I've seen the transformations now. I'm just going to extend this grid here. And that's 0, obviously, right? So that's a third, 2/3, 3/3, so that's pi. So every 4, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So now 12. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12. Okay. So if you're willing to see the actual original function, and that's why you have to be careful with scale. That's the whole point of this, is that the cosine graph starts at a maximum. It starts at actually 1, right? And then the minimum starts at in between pi. So 1, 2, 3, 4, 5. That's pi over 2. And so this purple graph that I'm sketching, hopefully you can see this. This is actually the original function. And it has been compressed vertically, or compressed horizontally, squished, and stretched vertically. So this was the original. And then a lot of you see this question, amplitude period of 2 pi over 3. Okay. So I think that was actually pretty good. I don't think I needed question 3. Now the exercises here are pretty good, but honestly, if you can master the activities, you should be all right. Anyways, hopefully I was okay. And I thank you for keeping in sync with your learning. As always, feel free to email me at my email address that I provided for you from the Google Classroom. Have a nice day. Bye for now.